Lesson 5 in Chapter 7 is factoring linear expressions. And when I mention factoring with linear expressions, I want you to think of like backwards distributive property. So I'm going to already give you the end result after doing the distributive property, and you have to write it before the distributive property was performed. So what we do is we pull out the greatest common factor out of our terms. All right, now you can do this a few different ways. You can make lists and find which one's common. I like to do factor trees, so I'm going to show you how to do that with some of these. Again, it's up to you. So let's look at 21 and 27 in number 1. Okay, and I'm going to give myself some room here. So if I make a factor tree for 21 and 27, I'm looking at what are the prime numbers that make up those numbers. So 21 is 7 and 3, and those are both prime, so I can circle those. So 3 times 7 is what makes up 21. And then 27 is 9 and 3. 3 is prime. 9 breaks down into 3 and 3. So for this one, I have 3 times 3 times 3. Now, I always think of this as a marriage ceremony, and if you were in class, we'd kind of perform a marriage ceremony here, but you want to look at what can be matched up. In a marriage, they say two people become one. So in this case, it looks like we have a 3 and a 3 get married and become 1, 3. Nothing else is in common, so it's just the 3 as your greatest common factor. Now, what we didn't pick, we are going to use when we get into the factoring. All right, let's look at another one. Let's look at number 9. You have 15x to the third and 18x. All right, so 15x to the third, you've got a 15 and an x to the third. Now, if I break apart x to the third, that's x, x, and x. All right, 15 can be broken down into a 5 and a 3, and both of those are prime. So we are left with a 3, a 5, an x, and an x. And 18x breaks down to 18 and x. There's only one x, so we can circle it. 18 is 6 and 3. You could use 9 and 2, but whatever you want to use, you'll still get the same answers at the bottom. And then 6 is 2 and 3. So for this one, we have a 2, a 3, a 3, and an x. So again, thinking about marriage, a 3 and a 3 get married and become 1, 3. And it looks like we have an x. An x and an x get married and become 1x. So 3 times x is 3x as our greatest common factor. All right, so let's use this to factor then. Okay, so let's look at, let's go with number 15. You have a 9m and you have a 12. So this breaks down into a 9 and an m. The 9 needs to be broken down into a 3 and a 3. So you have a 3 times m. The 12 breaks down into a 4 and a 3, and a 2 and a 2. All right, let's see what can get married. Looks like a 3 and a 3. And that's it. So 3 is your greatest common factor. So what you're going to do is that's what's going to go on the outside of your parentheses. Now what you didn't use is going to go on the inside of the parentheses. So notice under 9m, we had 3m left over. That goes under the 9m. And then under the 12, we had a 2 times 2 left over. Well, 2 times 2 is 4. And then just check yourself. Does 3 times 3m give you 9m? And does 3 times 4 give you 12? It does. So you know you factored it. All right, let's look at 20. You have a 4n squared and a 16n. 4n squared is n, and 4 is 2 and 2. So for this one, you have 2, 2, n, 16n, 4 and 4, 2 and 2, 2, 2, and 2. All right, so then you have a 2, a 2, a 2, a 2, and an n. So let's see what gets married. A 2 and a 2. Make 1 and 2. Sorry, 2. A 2 and a 2. Make another 2. An n and an n. Make an n. So it looks like our greatest common factor is 4n. So we're going to rewrite this. Okay, 4n is going to go on the outside. What did you not use for 4n squared? It looks like an n, so that goes first. Put your plus in the middle. What did you not use under 16n? 2 times 2, which is 4. Again, just double check yourself. 4n times n is 4n squared, and then 4n times 4 is 16n. And you're factored. Okay, you can try the rest of these. In the word problems, they tell you exactly what to factor, so you're just doing exactly what we did in the examples I just showed you.